Welcome to another community planning conversation. Today, the conversation is with Don Foumier. Don is associated with the Building Research Council at the School of Architecture in the College of Fine and Applied Arts at the university. Don, thank you so much for spending the afternoon with me. I'd like to begin with asking you to tell us a bit about your educational background and some of the different job roles you've had that have led you up to what we're going to spend the afternoon talking about, and that's mainly green construction and sustainability.
Well, like everybody else, I've had a very varied path to get here. My formal education is I have a bachelor's in electrical power from University of Massachusetts and a master's degree in mechanical engineering from UMass, and that emphasis was on air pollution. So I started my career actually designing nuclear power plants, and then I saw the error of that path after a couple of years. Basically, I was working with General Electric, and they had about 60 plants canceled in 1975 or so. So I chose a different path. So I went to work for the Army Corps of Engineers, and I spent the next 26 years with the Army Corps, basically doing building issues and energy in buildings and energy efficiency and building systems. I used to travel all over the world consulting on problems with buildings, with new construction or older buildings. And I spent 7 years in Europe. At the headquarters of the U.S. Army Europe, I was the senior mechanical engineer for Europe. So, and then at the end of my career, I came here to the Construction Engineering Research Laboratory up in northern Champaign.
What we affectionately called Searle,
Searle,
right?
yeah.
Right.
I was
Okay.
up at Searle for my last 10 years as a Fed, as we say. And I retired out of there. But one of the last things we got into were the issues of sustainability, green building design, energy issues, what is the future going to look like, how we're going to deal with sustainability. And I still consult back to Searle. I'm working on a project called a Strategic Sustainability Assessment. Even today, we're looking at projecting 30 years out, looking at the issues of sustainability for military installations and urban growth around them, and the issues of what we call encroachment. And so that's part of what I'm doing now. And the other part is I'm very active with the U.S. Green Building Council, involved in sort of developing green building rating systems, the sort of the care and maintenance of those as we upgrade them, and they become about every 3 or 4 years we sort of upgrade the rating systems on green buildings and put it out and bring us up to date standards and those types of things. And the other piece of my time, I'm managing something called the Smart Energy Design Assistance Center, which is a state-funded project for the Department of Commerce and Economic Opportunity, where we are helping small businesses become energy efficient to improve their bottom lines and keep businesses in Illinois. And we do that service free.
Is that out of Building Research Council?
Well, yeah, we do it at the university. It's housed at the Building Research Council,
Okay.
and we have partnered with the Geothermal Heat Pump Consortium to bring this program to the state.
Excellent.
So,
Excellent. Before we get deeply into our conversation about green building and sustainability, I just want to remind our viewing audience again about the upcoming 2006 Planning Institute that's sponsored by the Department of Urban and Regional Planning at the university. And a nice connection with this year's program is a session on green building and green schools, something that we will be talking a bit about this afternoon. If you're curious about the program at the Institute, you can go to our website, and that is very easily www.urban.uiuc.edu/CE for continuing education, and look at the program, and you will see the interweaving of most of the topics that are at the Institute this year with things that are going on in our very own community here in Champaign-Urbana and the county with the visioning project that's going on within the county. Now let me turn to Don and start asking him, first of all, a little bit to explain LEED, That's capital L, capital E, capital E, capital D. Oh, I'm leaping ahead in
Well, that's okay.
his notes here. You mentioned that very briefly when you were talking about something that you're quite involved with at the Green Building Council. And this may be a term that people have heard or read in the newspaper or in print or heard on a television program, and this is a good opportunity for you to help them get a better understanding of the program and why it's so important.
Yes. Basically, as Patsy said, LEED stands for Leadership in Energy and Environmental Design. And what it is it's a rating system where you can look at a building and go through, and it's a 69-point rating system, and actually score the building on how green it is, if you will. And actually, we've developed a whole family of systems. There's one called LEED for new construction, and then we have LEED for existing buildings, we have LEED for commercial interiors, and we have LEED for core and shell projects. And these two, the commercial interiors and the core and shell, sort of make up a whole building, if you will, and it's aimed at speculative construction to get that more environmentally friendly, if you will. And in development is a LEED for homes, which is for residential construction, and also in development is LEED for neighborhood development, which is a way to rate a neighborhood for how green it is. And specifically sort of aimed at new construction, new subdivision development, to encourage people to do that more in a more environmentally friendly area, a way of doing it. So most of my focus is on LEED for new construction, which is essentially most of the construction market is there right now in new construction. And the reason we developed the rating system is we felt that buildings have a pretty significant impact on the environment when you look at them all together. In the U.S., buildings consume about 65% of the electricity goes into buildings, which is residential and commercial buildings. The rest goes into the industrial sector. Although the electricity production is part of the industrial sector too.
Right.
And significant energy consumption there. And so about 36% of our nation's energy use goes into buildings. Those type, commercial and residential. And we're looking at about 30% of the greenhouse gas emissions responsible then from our buildings. And construction demolition waste, we're talking 136 million tons a year of construction waste from our construction process, which is about 40% of our raw material use associated with buildings. It's a major piece of our economy and responsible for significant amounts of waste. So,
and the embodied energy.
The embodied energy in the products that we put in our buildings, and also in the existing building stock. And for every 4 commercial buildings we build, we tear one down. And for every 6 homes we build, we tear one down. So there's a lot of demolition associated with construction, and then actually the waste that you get from the construction process itself. And that fills dumpsters and dumpsters of perfectly new virgin materials that end up at the landfill.
And the road wear to take it.
Road wear, and the trucks and the fuel they use and the emissions that they put out on the whole process. Where you get your materials from? Where do you buy your? Are you using mahogany from tropical forests that are being cut down illegally, or what kind of products are you using in your building? So and water too. Water is a big, buildings consume about 12% of our water. So we got together, and I've been in this since 1992. We started looking at these issues and developed the first rating system that came out in the year 2000. And the idea is to look at the issues associated with the building design and construction and operation. So we talked about issues associated with the site, with its water consumption, with its energy consumption, the materials that go into it, the indoor environmental quality in the building is very, very significant. That's where I say green turns into gold when you have a building that has good indoor environmental quality, good, healthy, effective workspace, and we can talk a little bit more. I was going
to say that I do hope that you will expand on that to help people understand when we talk about VOCs. That it's a term we use a lot, but the general public probably doesn't quite understand
what that's
exactly.
All about. Yeah. Okay. And we do reward some people for things like the innovation in design, these types of things. So we have a 69-point rating system, and you essentially build a project and you submit how you met these various credits in there. There's 69 credits, and you get rated, and you can either be a certified building, and then we have silver, gold, and platinum for the higher levels of environmental friendliness, if you will. And all the LEED rating systems are very similar in layout and construction, the way they are administered and function. As I say, then we're looking at also the existing building stock, commercial interiors, homes, and neighborhood design are the other, to sort of complete the LEED family of rating systems, if you will.
Would you mind putting your chart back
Mhm.
on there? Just a couple of things I wanted to ask about. I thought you were also working on a LEED rating system for higher education campuses. Is that something you're still doing?
The short answer is no.
Okay.
How that had turned out is that the USGBC actually felt that they were getting too many rating systems,
Okay.
and that product was sort of kind of getting washed out. So what we've done is also have a family of application guides, which can accompany the rating system. So most of them are developed around LEED for new construction. So there's an application guide in development for
Okay.
K through 12 schools. There's
Okay.
one for medical facilities, and there's one for laboratory space. There's one for retail. There's one for lodging, and there's one for campuses, which we call multiple building and campus projects.
Okay,
I
that's
chaired
a-
the committee that developed that one, and that one is out and done and on the USGBC website. You can download it as a PDF. So what we do is we take the rating system and look at it within a specific sector of the market, if you will, and help give guidance and hints for people to apply this rating system in that market, if you will. And certainly things come in, like if you're building a building on a campus, say like the University of Illinois, well, you don't have a boiler in a building, you don't have a chiller in the building, you connect to district water, you connect to district heat, you connect to district electricity even, we have their own electrical system. So how do you evaluate that as its energy efficiency and thing? We've developed techniques to look at the larger system and sort of, if you will, virtually put it in the building and get credit for the efficiencies of the bigger systems. And so, and other issues of site. How you use a site on a campus is different than if you're buying a commercial site.
Right.
And what are your boundaries and these types of things. So how you'd apply the rating system in that market. The same thing with retail, healthcare, labs, and K through 12 schools. And those other ones, retail is pretty well finished, and then the other three are in development, if you will, schools, labs, and healthcare.
And to do a little bit more tying together, the LEED for neighborhood development and LEED for homes. Last year at the Planning Institute, Doug Farr, a Chicago architect.
And he chairs that committee for
Exactly, and
USGBC,
he talked about how to, he's proposing a way of using the LEED rating and putting it into such a format that it could be used for the neighborhoods and almost as a replacement for zoning,
Yes.
as a whole paradigm shift on how we look at uses within a certain space. And Doug Farr, just for everybody's information, was very responsible with the renovation of a old factory building up in Chicago for the city of Chicago, and it's now called the City of Chicago Green Technology Building, and it's Mayor Daley's example to everybody in development within the Chicago area on how you can build green and renovate green. So it's a very educational place to stop by sometime and visit.
And it's open to the public. You can have
Yes.
self-tours. You can see all the interesting things. They have a green roof, which means a vegetated roof. They have
Yes.
photovoltaics with solar energy. They capture rainwater. They
Three-story cisterns.
yeah,
that
they have a
capture.
wetland on the site to infiltrate the water back into the ground, and it's an adaptive reuse of an old building
Right.
on a brownfield site
Right.
that they remediated as part of that project. So it's very interesting to see all the different things that they brought together to make, and that is a LEED 1.0 platinum building. 1.0 was the pilot system.
So that's
Yeah.
right at the top of the rating, isn't
Right at the
it?
top of the rating,
ratings.
yeah. And they actually have, I believe, 2 more platinum buildings now in the Chicago area, too. And Illinois is the number 3 state for green building. Most of it is focused in Chicagoland, but we have a few downstate projects, too. There's the Children's Museum in Normal.
Right.
There's the new business school at the universities, plans to be a LEED gold-rated building. And I'm involved with a project over on Prospect Avenue called Faith United Methodist Church. They're putting a big addition on, and that's we're looking for silver, possibly gold on that project, too.
Outstanding.
And we did things like porous concrete, kind of new in this area.
Very new in this area.
So the parking lot, the rains on the parking lot, and it goes down into the ground. We have underground storage of water, and then so we don't have any retention basin above ground. Very unique things, very energy efficient. Most of these green buildings on average use 30% less energy than the typical construction standards would be. And those are the latest standards, which are not necessarily in effect everywhere either.
Right. And this is a nice counter example to the parking lot, say at Farm and Fleet, which is no trees, all blacktop and total runoff, and no bioswales to collect any of that runoff
Right.
water and
Yeah.
recapture it and reuse it. It just goes down into the infrastructure
And disappears.
and disappears.
Eventually goes to the boneyard or Finney
Right.
Branch or one of those places.
and washes all the oil off that parking lot.
Yeah.
But all right. Well, that gives, I think, people a fairly good understanding of LEED, and I'm sure you'll talk about that and refer to it as you talk about some of the energy use. You've brought some very good overheads. So why don't you go ahead and give us some information on how we're using energy here in the United States and what we can be doing to move toward more energy conservation.
Yeah, well, what I'd like to do is just kind of quickly show you where the energy goes in the U.S. This is a flow chart that just shows you the sources of energy that we have and sort of where they go. And I know you can't read this, but essentially, you know, we feed the system with coal, natural gas, crude oil, nuclear energy, renewables, and imports. These are petroleum imports here and natural gas imports. Many people don't realize we import about 18% of our natural gas, and we import now in the 70% range of our oil. Very, very dependent on foreign supplies for these products. If you look at the imports, make up 33 quads of energy. And a quad is a quadrillion BTUs.
Wow.
Okay? Now that's 15 zeros. Okay? We use 1/4 of the world's energy. And we're less than 5% of the world's population. So we're a very energy-intensive nation.
We are, and folks in the other countries do not smile kindly on our overuse of energy.
And that means we also produce 1/4 of the world's greenhouse gases and several other implications associated with this. So all that energy goes into our energy mix, if you will, the electric power system in the grid or in the natural gas distribution system, and it pops out in sort of 4 places. About 21% of it goes into residential buildings, about 17% into commercial buildings, roughly 1/3 into industrial uses, and then 28% into transportation. So that's the way when we look at energy and where it goes. And so the inputs to this system are basically fossil fuels with a little bit of nuclear, a little bit of renewables. We're maybe 6% renewables, and that includes high-head hydro, things like this. So this is the Department of Energy's projection for the future. And if you can notice this graph,
see
everything
it? Okay.
continues to go up. This is U.S. energy projection. The top line is petroleum, natural gas, coal, nuclear, fairly flat, hydro renewables, fairly flat. Though both of those are fairly flat. And so that's the projection for the future for the U.S. Essentially up on a steady growth of 1 to 2% a year.
Right.
And if we look at those numbers for the world, it sort of comes to the same path, if you will, except this now is 4 times the energy in the United States. And we look at projections for oil consumption, projections for coal, projections for natural gas, and then renewables, a very slight increase, and nuclear, fairly flat, some slight increase. Although I'm not sure they're reading the tea leaves correctly on nuclear. China plans on building 20 nuclear power plants in the next 10 years.
Wow.
They're building almost 40 coal plants a year for electricity. They plan
Wow.
to quadruple their economy in the next 4 years, which would probably mean almost a quadrupling of their energy consumption.
Absolutely.
Okay, so that's the demand, if you will. So let's look at the supply of energy. The demand you see goes up, up, up. Well, this is the supply curve, and which is very interesting. This curve is from a group called the Association for the Study of Peak Oil.
Okay.
ASPO. ASPO.net on the web. This is a projection of oil and natural gas worldwide projection. This lower curve section here is what we call conventional oil. That's black gold. Up from the ground came a bubbling crude, Texas tea, if you will. That production of that worldwide is actually about at peak.
Okay, so that projection that we've heard talked about so much.
So much. We're living it today.
We are living it today.
And then there's other sources of oil, which we call heavy oil, extra heavy oil, which is mostly from Venezuela. Okay. It's a very thick oil that they process into crude.
And it takes a lot of refining.
A lot of refining. The other one is tar sands. Canada is king of the world in tar sands. It's very interesting. Now they're the number 2 oil supply in the world, theoretically oil reserves, because all of a sudden they're not tar sands anymore. They're now oil sands. Okay. We changed the word, and now Canada is next to Saudi Arabia as the king of oil. But it takes an awful lot of natural gas to convert that tar into something they call synthetic crude, which then goes into the feedstock of the refineries. A lot of environmental impact. It looks like the syncrude production alone in Alberta will take Canada off its greenhouse goals for the Kyoto Protocol.
Wow.
It has taken so much energy to do that. So, and then there's such a thing as deep water oil, which is going to peak here in another 15 years or so. And then polar oil, which as you see is this little white area, quite small. Turns out the polar regions are more natural gas provinces than oil provinces, so there's not a great deal of oil up there. A few billion barrels here or there, but when we use 40 a year, 40 billion barrels a year, then and then this curve is natural gas liquids. People don't realize when you produce natural gas, you also get liquids from that, which goes into the oil feedstock. And then this all is conventional natural gas up in here. So the subtlety here is this overall oil production peaks at about 2010. Now this is a pessimistic view of the world, but I think it's a realistic view of the world. And then natural gas, of course, we show the total peak of hydrocarbons that way, but of oil and gas. But natural gas is actually going to peak somewhere around 2035, somewhere in that range.
But even if the curve is off slightly by 10 years or 15 years, what you are explaining to everyone is that it's still on a downward slope.
It will eventually be on a downward slope. It may, whether it's 2015 or 2005. And believe me, 5 years from now or 10 years from now is not a lot of time to shift gears in your economy to think about something that is 40% of your energy supply, which is oil. So this sort of gives a thrust of why we say, why green buildings? Well, green buildings are very energy efficient buildings. And that's what we want, is better use of our energy resources. And the goal eventually is towards what we call zero net energy buildings.
Right.
And that's the ultimate goal. And this is why the various professional societies like the American Society of Heating and Refrigeration Engineers, they keep kind of cranking down how much lighting you can have in a building, how much energy you can use for heating and cooling, and trying to get the buildings more efficient, with the goal of eventually trending towards what we call net zero energy, where the building will produce most of its energy year round, but at times of the year we'll have to take from the grid, but at times of the year we'll give back to the grid, and then we'll have a net zero energy. And they're actually building residential housing units and looking at commercial buildings, and done some demo projects around the United States in different weather climate regions to actually show that this can indeed work in New England or Minnesota or Illinois or Florida or California, whatever. The whole idea is that it has to work everywhere. And of course, there's certainly different technologies that would go into a building. So that's a big piece of why green buildings is they need to be much, much more energy efficient.
To affirm what you've just explained to everyone, I do know an example, private residence in Quebec that is totally off the grid. So if it can be accomplished in that very cold climate, snowy climate of Quebec, we know that it is an ethical principle that we can use around the, actually around the globe.
Yeah, and so we talk about the idea of the U.S. Green Building Council is we want to sort of transform the market. We want to be more environmentally friendly buildings, and it's more than just energy. It's the materials that go into these buildings. How well are they ventilated? How do you control that ventilation? We find out that many buildings are very poorly ventilated, and then you have what we call sick building syndrome. People in the building have respiratory problems. They have asthma issues, and we're finding schools and almost many of our commercial buildings have very poor indoor air quality. The EPA now says that air inside is 10 times as bad as air outside. So we've done a pretty good job with the outside air, but we spend all of our time inside now, and people spend 90% of their time inside buildings. So perhaps we should pay attention to the type of building that we construct and how pleasant it is to be in.
Plus the loss of work time, sick
Yeah.
time, people take off because
Sure.
of these
We have
aspects.
studies have shown that if you double the ventilation in the building, it costs $40 a year per person in the building to do that. But it saves 2 days of sick leave, which is valued at $180. So that's a pretty good return on investment, factor of 4 in a year.
Yes.
That's what's that? 400% return on investment. So it pays to look
It
at
makes
these.
sense.
It makes sense. It makes sense.
It makes sense.
And so when we look at who's doing this,
Okay.
and about U.S. Green Building Council has about a little over 2,000, say 2,200 registered projects in the U.S. For every state.
And what does a registered project
Well,
mean?
when you want to get a building certified as green, you go to the U.S. Green Building Council and you register the project with them.
Okay.
Okay, and there's a fee. I think it's $450 to register the building, and then you eventually would submit. Use the rating system, certify that you've done a green design, and third-party certification from them that your building is green.
Okay.
All right. So, who's doing it? About 6% of the buildings are K through 12 education now registered. 7% higher education. Only 14% is commercial office space. Originally, that was half the buildings, and now the market is changing slowly. Half the certified buildings are office space, but they're only 14% of the registered projects now. It's spreading to other building sectors. Libraries, 3%, residential, multi-unit residential, 3%. So what we're seeing is a pretty good uptake by institutional folks, be it municipalities, school systems, cities. Several major cities in the U.S. are requiring green design, if you will, at some level. We're talking Austin, Texas, Chicago, Los Angeles, Portland, San Jose, San Diego, Seattle, San Francisco. Many of the major cities are moving in this trend. And then certain states are requiring that you build green. And we're talking California, Maryland, Michigan, New Jersey, Oregon, Pennsylvania, Washington, Maine, and the list goes on. I'd say Massachusetts probably should be added to that list now. And virtually the entire federal government is requiring a LEED type design. And they have a new agreement at the federal level between all the different departments of the federal government, how they're going to do this and what they're going to do. So almost all federal construction now will be green.
And to anchor this for people watching, Austin, Texas was the first community within the United States that passed a green building ordinance for their city. And you talked about the Children's Discovery Museum in Normal. And Normal is the only community in the state of Illinois that has a green building ordinance, and that came about because Mayor Coos of Normal felt that that was a very important aspect for their community.
Yeah. Yes, and the subtlety here is that they're requiring the private sector to do this, where most all the other municipalities, states, and federal government are just doing it for their own projects that they fund. But they're not. But the thing in Normal is that they're actually, requiring, I'm going to go in there and build a new bank or something, and I have to do it to green standards. That's pretty out there.
It is very much so. In fact, what Don is referring to is the new Bank of Illinois building in Normal has a LEED rating for it. And when you were talking about libraries being now 3% of this total picture of buildings that are being built green, neither of the libraries in our community decided to do that. Neither Urbana's new library nor Champagne's. And I know you were very involved with some of the thinking behind the Urbana library.
Yes, I was involved with the Urbana library. And what happened with that project, we were simply too late in the process to incorporate much of it. But we did incorporate into the design what we could. People can't see it from the ground, but it has a highly reflective roof to reduce heat islands. It has, you can't tell by looking at it, but it has very good windows. We specified excellent windows. We specified certain carpeting. We did low-flow fixtures in the bathrooms. So there's a lot of things we did within that design that we could sort of tweak as it was essentially designed by the time we started thinking about greening it up.
So a lesson from that is it's important to start thinking about this at the very beginning of the design.
At the inception of a project.
Is what you're saying.
Yes,
right.
yes.
Okay.
And which leads us to probably the next question is, what does it cost to do this?
Exactly.
And then why does it cost that amount of money? Well, on average, it costs about 1.84% to 2% to build a green building, an additional cost above the standard design.
Okay.
And it depends on how green you get, if you will. A certified building really doesn't cost much at all, less than 1%, which gets most of the lower cost things that you can do to green it up.
You mean like at the silver level?
At the certified level, which is one step below.
Oh, okay.
It's certified silver, gold, platinum.
I see. Okay.
Okay. There used to be, the pilot system had a bronze. We had bronze, silver, gold, and then platinum.
Okay.
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 And they dropped the bronze. Now it's called certified.
All right.
And that you can normally do for your normal construction cost. Just pay attention to what you're doing, how you write specs. A good architectural firm will get you there for no cost at all.
Okay.
And then as you sort of climb the green ramp, if you will, some things can be a little more expensive. But what we're finding is if you really go in from the beginning and do a truly what we call integrated design, where the design team actually talks to one another and works together as a team, people don't realize that. You think that happens with a building, but mostly what we call linear design occurs. Linear design means that the architect draws up this wonderful structure, throws it over the petition to the structural engineer who figures out how to make it stand up. He gets all done. He throws the drawings over the wall to the plumber, the P&ID guy, or
the HVAC person,
or the electrical guy, the lighting guy, and every discipline comes in and sort of does their own thing in this building, makes the worst assumptions they can make about the other guy as part of the design, and so it gets way over designed, and you end up each discipline optimizes for themselves, and then they do what we call pessimize the whole. And so in integrated designers, you actually get this group together with the owners and the users, and you have a meetings. You have what we call charrettes, and you discuss this whole process, and you talk about how you're going to build this building, what the goals are going to be, and the disciplines work together. And actually, when a guy designs the mechanical system, he actually believes, the electrical engineer, that it's only going to be 1 watt per square foot for lighting, not 3 watts per square foot. So he doesn't design the air conditioning too large. Or the
Which
boiler too
is
small.
usually a really big
Yeah,
problem.
yeah.
The,
Or
the,
the-
heat,
yeah.
the heating and air conditioning are
Right.
over-designed.
Over-designed.
Yeah.
Everything is over-designed.
Yeah.
And the windows are all part of the design. So the idea is that you do this integrated design, and actually you can do those buildings for almost no cost as far as the construction aspect. They may cost a little more to design because it is a greater design effort. But what happens is you build a better envelope, you reduce the loads in the building, so the heating and ventilating air conditioning system can be smaller and therefore cheaper. And take the money you saved on that and put it into better windows and better materials and more insulation. And this is the integrated process, we call it. And that's how you get a green building for a little or no money.
But now, I'd like to do that. I'm an owner, and I'd like to comply with all this, and I'd really like the gold of a platinum rating.
Yeah.
Are there some grants that I can apply for that might help offset some of the increase of costs, and so maybe it won't cost me actually more than standard construction because I've been able to get some help along the way to encourage me to do this kind of building?
The short answer is yes. If you're a nonprofit, whether you're an agency of government or a religious institution or some other nonprofit entity, you're going to build a building. Within Illinois, they have something called the Clean Energy Community Foundation, and you can apply to them for a grant. And they will generally pay the additional costs of the lead registration, the extra design costs, and some of the mechanical, if there's any extra cost of mechanical equipment. They typically grant in the area of maybe $100,000 in that area, which is enough to, pay for these little extras. Now, some states, like Massachusetts, and schools, they've discovered that green schools are really a very effective thing to do. So the state actually will kick back to the school district that 2% cost, if you will.
Okay.
And so what happens there is they bring the net cost to the district of that school for a green school typically cheaper than the regular thing that they would have built. And then the green school has daylighting, has very good lighting, has very good heating, ventilating, air conditioning. People actually get fresh air when they're in the building, these types of things. And they find, the benefits of that, it costs maybe, a school costs about $200 per square foot to build. And the green costs are about $4 per square foot, and that's what they kick back. But the life cycle savings of that are, just the energy and water savings are $15 a square foot. If you incorporate all the intangibles, which is teacher retention, children learning better, and then going out and be productive members of society and get better jobs and pay more taxes and all these things. Reduction in air pollution emissions and the social costs associated with that. You add all these things up, and it's $60 to $70 per square foot present value. For a $4 per square foot investment,
Right.
You're getting 20 times return on your money. And it's sort of in the area we call sort of a no-brainer. Why aren't we
Exactly.
doing this everywhere?
Exactly.
And so it's very, very important. And because they've done studies and they've shown that kids in green school have higher test scores, less ADD, less ADHD. It's just phenomenal what goes on in these buildings. And
I want you to hang on to the green school I did because we want to talk about that more. But before we leave, the Green Building Council and the Green Energy Agency here in the state of Illinois, why don't you tell people a little bit more on how they can contact these people? So Jim Mann is director of the
the Clean Energy
Clean Energy
Community Foundation.
And I know that the church that you mentioned that in Champaign that's Building Green got some assistance from them,
Right.
and
They
I
got a
also
grant, yeah.
right, and I also know that the Children's Discovery Museum in Normal got some assistance from them, and in fact, their grant was used for the architect to design that building Green, and they can find that information if they do a search on the internet. Is that correct?
Yeah, just community, Clean Energy Community Foundation. It's one of the CECF. I think it's CECF.org.
Okay,
I think-
cecf.org for that one.
Yeah.
And then can you
Yeah.
give them the website for the U.S. Clean Building Council
Yeah.
in case they'd
Yeah.
like to learn a little bit more about LEED rating?
Sure, you can explore that. You can download the rating systems. There's a lot of information on the web. That is just www.usgbc.org.
Okay.
U.S. Green Building Council.
Okay, that will,
And as far as finding money out there, Kresge Foundation will also fund some of these things.
okay.
So,
And then you can find
Just-
Kresge
just Google,
Foundation
yeah.
by Googling
Kresge
Kresge Foundation.
Foundation.
So there, we've talked about several avenues of resources to help offset some of these additional expenses that do come into play when you are considering building green. Now, back to green schools. But I just wanted everybody to get that background information in case they were interested in it. Green schools are really an important topic, not only for what you've just talked about, but we have an issue very close to home, shall we say, here in Champaign, because we all know on the upcoming election, there's going to be a referendum, and part of that referendum is funding for 3 new schools in the city of Champaign. So I'd like you to talk a little bit more about this report that you brought and what is happening in Massachusetts, and explore further and in more depth some of those ideas that you just talked about before I interrupted you.
Okay. Well, I have a sort of a hot off the press report, if you will. It's called a National Review of Green Schools and the Costs, Benefits, and Implications for Massachusetts. And this study was done by Capital E, which is a company for the Massachusetts Technology Collaborative, which is the organization funding the Green School Initiative in Massachusetts.
And now the Green School Initiative is at a state level, is that correct?
Yes, it's statewide, and they've
Okay.
built, I think, well, this study looks at 30 schools nationwide, and I think 12 or so of the schools are in Massachusetts
Okay.
that they looked at. And essentially what they found is benefits from a green school that reach across the whole spectrum of the economy.
Okay.
From it's reduced energy consumption, it's reduced emissions, it's reduced water and wastewater consumption, and then what they talked about, increased earnings, asthma reduction, cold and flu reduction, teacher retention, employment impact. Those are the sort of the fuzzy intangibles, if you will, of green building. That's where, that's the area where I say green turns into gold, is those intangibles where you can have an impact on the lives of your students, the lives of the people who work in the building. It's very, very interesting. They've done studies of say, daylighting is a big aspect of green design, much more. Turns out that 2 things go on. When you're in a learning environment and you're trying to learn some information, every now and then you have to stop focusing directly on your book or the board and turn and be able to focus your eyes in the distance. And then the synapses in your brain can lock in and make this connection, and the learning process goes on. So what did we do in the 70s when we took the windows out of our schools to save energy? We made them bad places to learn. And so we're finding now we really need to go back to these schools, tear out those energy panels, if you will, put the windows back in, and today's Windows technology is far superior to what we had 30 or 40 years ago, and get daylight back in the schools and get decent lighting up there. New technology that has a fuller spectrum of lighting and is better for the human eye to work with. And all this. Just, things that we find over and over. Ventilation, sickness. We find that kids have less ADHD in these schools. And it's the same thing. They can settle down. They can look outside. Nothing wrong with looking out a window every now and then. And if they see a tree, it's even better. We find that if a child just walks to school and passes through a park or some trees or some natural landscape, they have less issues of ADHD for those children during the day. It's phenomenal what there's over in NRIS. There's some folks doing research on these things.
Yes, there are people at
Yeah,
NRIS
yeah,
doing that.
yeah,
NRIS is one of the departments over in our College of Agriculture, and they've been looking at the issues of behavior and safety related to the built green environment. Yes,
yeah.
indeed.
So,
Some of the things that are in this report, how do we, for our own community, capture these in relationship to what our present schools? Is there something we could do with our present schools rather than think about the need of having to build 3 new schools? And the other issue that it seems to have a lot of attention in our newspaper and letters to the editor are the air conditioning of schools. You've been talking about how you can structure schools so there's better airflow and cleaner air inside. Are these some things that we can adapt to schools that already exist?
Most certainly. Today's technology is significantly more energy efficient and is capable of providing better indoor conditions, if you will. So certainly we want to consider, if we're going to renovate an existing school, well, first, get some decent windows in there and get windows back in, put some new modern technology lighting in there. You don't have to wire for the internet anymore. There's a little term called wireless now. We're talking about wireless cities and communities.
Right.
Well, that can work in a school pretty well, too. The University of Illinois is pretty much going wireless. New HVAC systems, and a good one is a geothermal heat pump, a ground-coupled heat pump system that, for the same money, you get heating and cooling. Equipment-wise, it pumps heat to and from the ground with the same piece of equipment, so it doesn't cost more to get air conditioning, and they're very efficient. And when we look at projected energy costs in the future, even though we're expecting a significant jump in electrical prices next year. In the long run, natural gas and fuel oil and some of these other energy costs are going to be significantly higher in the future. And DOE is even admitting now natural gas is going to be more expensive
DOE
next year.
meaning the Department of Energy.
And it turns out we dodged the bullet this year with the warmest January on record.
Yes, we've been very
Okay.
lucky, even though our power bills don't seem to indicate our luck.
Natural
but
gas has actually dropped 24% in price in the last month.
I know,
So,
it's,
yeah.
but
Yeah.
the prices are not going to go down. It's the same way
Yeah.
with your
Yeah.
graph that you were showing, that we're peaking, whether we peak at 2010 or 2015.
It doesn't matter.
And the resources are going to go down, that means the cost is going to continue to go up.
Because what's
And-
happened, because energy is a world market today, and the world demand is increasing. The supply is stagnant of oil and natural gas, going up very little, and the demand is, say, 2 to 3% per year. The supply is increasing 1% per year. You see it in the cost of the product is then how that is reflected, and then you ration through pricing, and that's what we're seeing, and you're going to see more of that. As I say, you ain't seen nothing yet.
Until what's happening. It's very clear we need to have a second conversation and just focusing on green schools. Again, I want to remind everybody about the Planning Institute that is coming up the 2nd and 3rd of March, and there is a session specifically on green communities and green schools. So some of what Don didn't have time to go into great depth on green schools. You will be able to find out more about that. And if you have, I hope this is okay, if you have further questions about this information on the Massachusetts report in green schools, because that specifically is applicable to things that are about to happen in the Champaign community, that Don Foumier is at the Building Research Council. And in case you aren't acquainted with where that building is located, it's on St. Mary's Road, the south edge of the university campus. And that council is associated with our School of Architecture at the university, and their purpose is for research and education. So please feel free to contact them if you have further questions on this report or any of the other energy issues that he talked about today. Don, thank you so much for coming and joining us today, and thank you for watching Community Planning Conversations.